Hi class, if we look back to section 1B of chapter 5, I talk about what determines air pressure, and we mentioned that three things that determine air pressure is the pull of gravity, which we've looked at already, the mass of the molecules, which is related to humidity, which is what we're going to look at not right now, but next. It'll be the next thing we look at. And right now we're going to take a look at the amount of pressure that's determined by the kinetic activity of the molecules. In other words, the temperature of the air. So the temperature of the air will have an influence on the air's pressure. Okay, and so you can think of this as being kind of a domino effect. Okay, and so first we're going to take a look at a warm column of air. Okay, so on the right hand side here we have a column of air that is filled with warm air. Okay, and so when you increase the temperature and warm up the air, like I said, it's going to be almost a series of dominoes, so we can follow the trail of the dominoes here. So when the air temperature warms up, that increases the average kinetic energy of the molecules that make up the column of air. When you increase the average kinetic energy of the air molecules, you're going to increase the spacing between those air molecules. Okay, they're going to be vibrating around like crazy, and that's going to increase the spacing between the air molecules. When you increase the spacing of the air molecules, that's going to decrease the density of the air. Okay, and when you decrease the density of the air, that's going to reduce the pressure exerted by that column of air on the surface. Okay, and so as a result, what we find with a warmer column of air, that warmer air is lighter and less dense than cold air, and therefore exerts less pressure on the surface. Okay, so the warmer the temperature, the less pressure exerted on the surface. We can simply turn that around and take a look at cold air, a column of cold air. So when air temperatures decrease, that's going to decrease the average kinetic energy of the air molecules. They're going to be more sluggish, so that when you decrease the temperature, decrease the average kinetic energy of the air molecules, that's going to reduce the spacing between the air molecules. Okay? And when you reduce the spacing between the air molecules, you're going to increase the density of the air. When you increase the density of the air, you're going to increase the pressure exerted on the surface. Okay? And again, remember your definition of air pressure. It's the force exerted by the weight of all of the air molecules above the surface. So when the air is colder, there are more air molecules above that surface, and therefore we find that with colder air is heavier and more dense than warm air, and consequently exerts greater pressure on the surface. Okay, so that's the second way, the second influence on air pressure. The first one was the pull of gravity. The second one was the average kinetic energy of the air molecules, in other words, the air temperature.